Synthetic division with completing the square, pre-calculus, pre-college math. All right, the previous video and lecture, we learned how to do division with synthetic division, and that got us quotients, remainders, and so on and so on. What we're doing now is we want to find all of the roots of a function. And so I'm actually going to skip this example here on number 1 because it's actually almost a little too easy. So skip this for now. Sorry. Skip this. And let's take a look at the number 2 problem. So use synthetic division and completing the square to find all the roots. Now, this is an x cubed term, meaning the highest exponent is x cubed. And what that means is there should be 3 solutions or roots. Remember, solutions and roots, we use those terms interchangeably. So what's going to happen is I'm going to give you one of them. I'm going to tell you that -1 is a solution to this polynomial, to this function, and I want to know the other 2. The way we're going to do that is we're going to start off by using synthetic division to divide -1 out from this polynomial. What that's going to leave us with is, remember, when we take one root out, we're left with an x squared term, a quadratic. And from there, we're going to use completing the square from the previous chapter to find the other 2 remaining roots. So there's actually nothing new in this video you haven't yet done. It's just kind of putting 2 topics together. So first we do the synthetic division. All right, so we write the polynomial up here without the variables. So 4, -20, 7, and 31. And then we put our bracket around it and our root -1 out here. Then we bring down the... Sorry, I'm having some tablet problems. Bring down the 4. Multiply by the -1 to get -4. Combine to be -24 times -1 is +24. Combined with 7 is 31. Times -1 is -31. And we get a remainder of 0, which is important because I'm telling you it is a solution. It's a given solution, so you better get a remainder of 0. If not, then it's not a solution, and then we have some problems. We will be testing potential solutions in the next lecture, actually, but this one you're going to be given a solution, so you can guarantee that should be a 0 or something is wrong. And then we fill in the variables around it. So right, that's 4x squared minus 24x and plus 31. So what I'm left with is my quadratic, 4x squared minus 24x plus 31. And this is the quadratic that I'm now going to do completing the square for. Remember, there are 3 solutions. I have one of them. One of them is -1. I want to know the other 2. And so the other 2 I can get by solving for this by completing the square. More quadratic formula, but we're going to do completing the square. So this was in the previous chapter, so it might take a little refreshing, but we're going to first set it equal to 0. So 4x squared minus 24x plus 31 equals 0. And then we rewrite it so that the constant, this 31, is on the other side. So 4x squared minus 24x equals -31. Then we divide everything by the number in front of x squared, if there is a number in front of x squared. Sorry about these annoying boxes. It's tablets being a little weird today. So when we divide everything by 4, we're left with x squared minus 6x equals -31 over 4. And just trying to move this away out of the way. Come on, go away. All right. So, I'm sorry, I'm sure these boxes are very distracting. They're distracting to me. All right, so we set it equal to 0, move the constant over, divide by any number in front of x squared, and that got us to this point. X squared minus 6x equals -31 over 4. Then we do the b divided by 2 squared phase. And the b divided by 2 squared, in this case, the b is the -6 term, so divided by 2 is -3 squared is 9. So we add 9 to both sides. So negative 31 over 4 plus 9. Factor the left to be x minus 3 squared. Combine the right. You can do this part in your calculator. Comes out to be 5 over 4. Okay, because 9, I can tell 9 is the same thing as 36 over 4, and 36 plus negative 31 is 5 over 4. But you could do that part in your calculator, which most of you do. Square root both sides. X minus 3 equals, now the square root of the right side requires a plus or minus in front of it. The square root of 5 cannot be reduced, so it stays rad 5, but the square root of 4 can, so it's over 2. Lastly, move that 3 over. You get x equals positive 3 plus or minus rad 5 over 2. So that, along with our negative 1, we have our 3 solutions. So our 3 solutions, put them all together, x equals negative 1, which is a real solution, real and irrational solution, then 3 plus or minus rad 5 over 2, and this is 2 irrational solutions. This is a total of 3 solutions down here. Remember, the plus or minus is what separates it. Like I could write 3 plus rad 5 over 2 as one of them, and then 3 minus rad 5 over 2 as the other, but I don't mind keeping them combined like that for now. And that is basically it. So you're going to be given a root, synthetic division to get it down to a quadratic, and then complete the square of that quadratic to get the 2 other remaining roots. And those 2 roots could be imaginary, they could be irrational, like in this case, or they could come out to be rational things like 5 and 7. That depends on the problem. All right, but you are going to end up with 3 roots total when you have an x cubed term. All right, so we'll practice some more of this tomorrow.